For me, good evening for you. Hello, and welcome to the Rasa Reading Group. I am joined today with Dr. Adam Lopez, who I will allow to introduce himself while I have some coffee. Why don't you kick us off?
Okay. Hello, everyone. I am Adam Lopez. I am the new-ish research manager at Rasa. So I'm just joined the research team early July, and I have been working in NLP for a long time, about 20 years. And I'm still affiliated with the University of Edinburgh, where I'm based.
Thank you for joining. And actually, I think you joined just about the time this paper came out, right? Because it was like right during ACL.
I
Um,
yeah.
I was going to say, Enrique says, new doctor on the block. Welcome.
Thanks.
So this paper, y'all chose by voting. Thank you for voting for this one because it's one that I really wanted to read. It is Climbing Towards NLU on Meaning, Form, and Understanding in the Age of Data. And it was from, ACL 2020, which was all online. And the authors are Emily Bender and Alexander Koller, I think. And I actually, disclaimer, know Emily quite well because I got my PhD at the University of Washington in the same department, the Department of Linguistics. So we've hung out quite a bit at this point. Kuba says, 20 years, wow. Faisa says, hi doctor, glad to see you again. Hello, hello, hello. And Anand says, thanks guys. I don't know what you're thanking us for, but you're welcome. All right. And when this paper came out, there was a lot of discussion about it on Twitter, which is the main way that I've interacted with it. We haven't read it previously. So why don't we just kick it off? And I can start with the abstract, and then we can say what we have to say. And then if you want to hop in with the introduction, Adam.
Sure, I will. Maybe I should say also as disclaimer, of course, I know both of these authors as well.
Doesn't mean we're going to be like fair in our assessment, hopefully. The success of the large neural language models on many NLP tasks is exciting. An example of such a large neural language model would be, for example, GPT-3 or BERT. However, we find that these successes sometimes lead to hype in which these models are being described as understanding language or capturing meaning, in square quotes. In this position paper, we argue that a system trained on form has a priori no way to learn meaning. In keeping with the ACL 2020 theme of taking stock of where we've been and where we're going, we argue that a clear understanding of the distinction between form and meaning will help guide the field toward better science around natural language understanding. Some terms people might not be familiar with, position paper. Do you want to talk about that a little bit, Adam?
Sure. I think this is a little bit more of a synthesis of various ideas rather than sort of an empirical research paper, which what Emily herself, I think, calls an NLP engineering experiment paper, which is by far the dominant form of paper that appears in most conferences. And I think that this particular form, so ACL has taken survey papers for a few years now. And they were quite deliberately sort of solicited more position papers for this particular conference. And this was one of several that was actually quite interesting. There was also another paper by Tal Linzen, which is sort of thematically related to this. And there was another paper by Anna Rogers, which the Bertology paper, which I think is sort of in line with at least some sections of this.
Okay. And just a survey paper is something that's like, here's all the things that's been done on X to date.
Yeah. And as there are 600 papers published in most conferences these days, this is increasingly important as to how people actually synthesizing ideas and sort of taking a big picture view.
Definitely. And an important part of scholarship in general. All right. Do you want to... Oh, one sec. We have some... Ravi says, both NLP doctors. Yeah, I think my degree's technically in linguistics. Yours is... You're at UMass, right?
Maryland.
One of the M's. But it was it in linguistics or was it in electrical engineering?
It was my PhD. All my degrees are actually in computer science. My advisor was in the linguistics department, and so as a consequence, I don't really sort of respect disciplinary boundaries very much.
Disciplinary boundaries are for suckers. Well, and Krishna's excited to be here. We're excited that you are here. All right, let's hop into this introduction.
I think this is me.
This is you. Yeah, okay. Sorry, that was your cue.
The current state of affairs in NLP is that the large neural language models, such as BERT or GPT-2, which we could update to GPT-3, because I don't think that will change the argument of the paper, are making great progress on a wide range of tasks, including those that are ostensibly meaning sensitive. This has led to claims in both academic and popular publications that such models understand or comprehend natural language or learn its meaning. From our perspective, these are overclaims caused by a misunderstanding of the relationship between linguistic form and meaning.
Yeah, I would agree. I think it's hard to be in this space right now and not have come across like language is solved sort of arguments, or like I think someone compared GPT-3 to talking to 10 PhDs in different disciplines, which maybe like the documents, maybe like querying in people's dissertations, but not quite talking to people. I'll take the. Okay. Yeah. Do you want to take the next paragraph, or shall I?
I'll go ahead for a bit.
Please.
We argue that the language modeling task, because it only uses form as training data, cannot in principle lead to learning of meaning. We take the term language model to refer to any system trained only on the task of string prediction, whether it operates over characters, words, or sentences, and sequentially or not. We take linguistic meaning to be the relation between a linguistic form and communicative intent.
Yeah, this is core linguistic stuff. This is, Saussure. So basically, this is building on this sort of core idea in linguistics and philosophy of language that there is nothing inherent about the word cat that means cat, right? We have that relationship of meaning that, like a cat, so they're small, they're cute, they're purr, they live in your house, and that connection is made socially and through repetition, but it's not encoded in like the character sequence CAT. And it gets a little bit fuzzier when you get to languages, because a lot of those things, a lot of signs do have a clearer link between form and meaning, but certainly for written and spoken language, it is tenuous at best.
The arbitrariness of the sign.
Yes. Taking it all the way back to my linguistics 101 education. I can take the next little bit. Our aim is to advocate for an alignment of claims and methodology. Human analogous natural language understanding, NLU, is a grand challenge of artificial intelligence, which involves mastery of the structure and use of language and the ability to ground it in the world. While large neural language models may well end up being important components of an eventual full-scale solution to human analogous NLU, they are not nearly their solutions to this grand challenge. We argue in this paper that genuine progress in our field, climbing the right hill, not just the hill on whose slope we currently sit, depends on maintaining clarity around big picture notions such as meaning and understanding in task design and reporting of experimental results. Yeah. Do you have something you wanted to say about this?
Yeah, there's a lot to agree with here. I think I'm sort of reminded of something that I read, and I can't remember who to attribute this to, that, a lot of sort of machine learning approaches to language understanding are, or at least when they explicitly aim for language understanding, are something like trying to go to the moon by climbing a tree.
Yeah, let's keep reading. I've got a lot of thoughts, but it's too, I'm going to wait until they're a little bit more organized to share them. Let me put it that way. And then I can take the next paragraph, and you can take the next session. That's a really good question. Sorry, Dikesh popped in. What do the authors mean by models using form as training data? And Alan says +1. So the surface form of the language is in text, just the string of text characters that you get. So those might be, Latin. What are our characters called? Like the alphabet. What is the alphabet called? I was like, it could be like Chinese characters or Arabic characters or ours.
I think it's a Latin alphabet.
Latin alphabet, thank you. A little bit more coffee. So as opposed to, I guess a complementary approach would be something like an agent system where you're modeling the relationships between things in the world and like what will happen if I push this picture over, and then also having a language component on that moves towards the surface form. Yeah. I don't know. Do you think I did that justice, Adam?
I think so. I mean, I think they're making a very specific claim here, like about these specific types of systems that are mentioned in the very first sentence of the introduction. Sort of BERT and GPT and the other pre-training type models.
Yeah. Next paragraph. After briefly reviewing the ways in which large language models are spoken about and summarizing the recent flowering of Bertology papers, symbol 2, I think it's a footnote.
That's the text section symbol.
Oh, it's the text section symbol.
One of my favorite symbols in LaTeX.
What's it called?
It's just /text section.
Oh,
I think
/text section 2.
I think it's commonly used in like legal documents or something. There's like a handful of us in NLP that use this.
Interesting. I learned something today. So to talk about the Bertology papers in section 2, we offer a working definition for meaning, section 3, and a series of thought experiments illustrating the impossibility of learning meaning when it is not in the training signal, section 4 and 5. And this is where I think the most discussion on Twitter came from. We then consider the human language acquisition literature for insight into what information humans use to bootstrap language learning, section 6. I'm wondering how deeply they're going to get into the embodied literature, or embodiment literature, rather. And the distributional semantic literature to discuss what is required to ground distributional models, section 7. Section 8 presents reflections on how we look at progress and direct research effort in our field. And section 9, we address possible counter-arguments to our main thesis. Alan says, you just need a taller tree, to climb all the way to the moon. I mean, if you can solve the problem of getting plants to grow in no atmosphere, more power to you. You want to start section 2?
Sure. Section 2 is large language models, hype, and analysis. Publications talking about the application of large language models to meaning-sensitive tasks tend to describe the models with terminology that, if interpreted at face value, is misleading. Here's a selection from academically oriented pieces with emphasis added. 1. In order to train a model that understands sentence relationships, we pre-train for a binarized next sentence prediction task.
And this is the BERT paper.
2. Using BERT, a training language model has turned machine comprehension. This is another recent paper. I don't actually recognize the reference. 3.
No, me neither.
The surprisingly strong ability of these models to recall factual knowledge without any fine-tuning demonstrates their potential as unsupervised open domain QA systems.
Ooh, that last one is giving me hives. Let's just quickly check the reference. It was language models as knowledge bases.
I think I have
and that was in
seen this paper,
EMLP.
not looked in detail.
Yeah, might be something I add to my reading list at some point. To be clear, language models I would argue do not do that, and please don't treat them like they do that in your development work. You will get burned.
If the highlighted terms are meant to describe human analogous understanding, comprehension, or recall of factual knowledge, then these are gross overclaims. If instead they are intended as technical terms, they should be explicitly defined. I would just say as like someone who works with a lot of people writing papers, yes, please explicitly define terms that you're using. And this is a really good example of where stuff like this might happen. I think there is a tendency, certainly in like CS, to use sort of general terms, take them off the shelf, and use them in with a somewhat specific meaning in mind. And then, if those are sort of terms that are in common use in the language, then they will sort of metastasize to, if they're easily misinterpreted. And so it might, it's certainly reasonable to think that maybe these people meant, in these particular papers, meant these in a narrower sense than the general understanding of these terms. But certainly if you leave it undefined, it's very open to misinterpretation.
Yeah. Like even in this paper, form. What does form mean? If it's not a term you've encountered before and you're not familiar with its specific definition, you might misinterpret that. I don't know. You might be like, it's forms that you fill out with a pen. I don't know. Oswaldo says, looks like a new community is forming around Dr. Rachael. I would say more that I'm a member of an existing community and I'm conning people to come into my show. It's not necessarily my show, but a show that I'm often on. Yeah, I can hop in with the next section. One important consequence of imprudent use of terminology in our academic discourse is that it feeds AI hype in the popular press. As NLP gains public exposure and is more widely used in applied context, it is increasingly important that the actual capabilities of our systems be accurately represented. Yes, this is, like, as a former researcher, current developer, this is absolutely crucial. In some cases, NLP experts speaking with the media are being appropriately careful, as in these two quotes in the New York Times. Sorry, lots of speech errors. These systems are still a really long way from truly understanding running prose by Gary Marcus, who has built, he's a senior academic, but certainly has a lot to say about language models and meaning. And I want to say he's at somewhere on the East Coast.
NYU, I think.
NYU? That sounds right.
Yeah.
And then Oren Etzioni, who I believe is the head of Allen NLP in Seattle. Although, actually, no, I don't think it's just NLP. I think he's the head of Allen AI.
AI too, yeah.
Yeah, which is a research group founded with, currently he wasn't the late when it was founded, Paul Allen. Though BERT passed the lab's common sense test, machines are still a long way from an artificial version of a human's common sense, which I think is accurate. Yeah, I'll read the next section too. And Shivam says, I agreed there is no signal for meaning in word, but meaning of a word is known from its neighbors. Oh, you're talking about distributional semantics. I will say that distributional semantics is, so I believe the quote is, you shall know a word by the company it keeps, from the original paper that I don't remember the citation for right now.
It's Firth, but I don't remember
some point in time, well before I was born. I will say that distributional semantics is one way of modeling semantics. It is not the only way to do semantics. And for semanticists, like people who study meaning in words, I would say that it is least often used less often than other types of modeling of semantics and meaning. They haven't gotten, they do not currently have as much traction in modern NLP as distributional semantics. Next section. However, there are plenty of instances where the popular